Here's a spreadsheet that you can download from the CDC's website. For links, go to sys3.com and search for Ebola. To clean up this spreadsheet, we're first of all going to change the dates so that they fit. So simply double-click between the A and B on the column, and that will spread things out. Likewise, let's wrap these title cells. So select them and click on Text Wrap. Notice that the data actually doesn't start changing from zeros until March 25th of 2014. So highlight rows 2 through 25 and right click and then delete. Next, let's insert a column so that we can track how long it has been since the start of the epidemic. This is day 0, so we set up a formula that says equals this minus itself, but let's do a $A, $2, which is an absolute cell reference. That one won't change. And then we need to format the date to actually be a general number and fill that down. Let's also add a column of numbers for the total deaths and total cases. Then we need a sum formula. We're going to take the New Guinea plus Liberia plus Sierra Leone and do the same for total deaths. If we highlight both of these, then use our fill down, we'll quickly add all of these up. And we're ready to graph the data. So let's give ourselves a little room to work here. Shorten these columns up a bit. Move this up to look at just the data. When you want to create a graph, simply click the column that you're interested in, highlight it, and then hold your Control key down to plot your second column. That allows you to get 2 discontiguous columns. And then insert menu, I apologize you can't see it, but we want to choose a scatter plot. And we can see the total cases. Back up, we're going to grab days since the epidemic started, column, and then the back up at the top, total deaths, Control key down. And we'll insert a graph again. This chart is going to be a scatter plot once again, and move it over here. So there's a bit of a change from the previous data that we saw in the first article about this, the first video about this. The nice thing about having it in Excel is you can see if you have an outlier. This looks like it's an outlier at 218 days into it, maybe over-reported or something of that nature. Same thing in the deaths area. And then you can also look at this logistics function now. It used to be an exponential growth, but you can see that this is definitely turning into an S-shaped curve, and the inflection point where that occurs is an interesting date, because that's when things are starting to stabilize and you're having fewer cases, fewer deaths. Now, the problem with using Excel for this is that when we right-click on the data and we try to add a trend line, we have exponential as an option, linear, logarithmic, polynomial, power, and moving average. And none of these are logistic curves. So as you can see, the exponential curve is not going to fit. It's not obviously a linear curve. Logarithmic didn't even give me an option. So it's best to grab the graphing calculator for this type of activity. So we'll pull a graphing calculator over here, and when we turn it on in our stat menu, we want to go to the edit menu and put in the data that we have here from the days and cases or days and deaths and so on. I've preloaded this, but it's simply a matter of typing in what should be in each of the columns. Next, go to the stat menu and you want to calculate. So we move to calculate and we want to choose what we believe is a logistics curve. So we press enter, and it needs to know what data we need to use to create the logistics curve. So we would choose to use second 1, which is your L1 value, with a comma, that's our X value, our days, and second 2 for L2, and then we press enter, and the calculator will calculate the logistics curve based on the data that's in L1 and L2. As you can see, I had already done that earlier. And it does take a while because there's a lot of number crunching that has to go on. So here's our equation. The calculator determined is the logistics growth curve that matches the data that we put in. And it says that y is equal to c over the quantity 1 plus a to the times e to the negative bx, where a is a little more than 749, b is a 0.03, and c is 22,977 and some change. So this equation can go into the y equals function, and I plugged all that in already. So y equals 22,000 over the quantity 1 plus 749 times e to the negative 0.03, and then we're ready to graph that. So if we simply click graph right now, chances are we're not going to be in the right zoom mode. And likewise, we want to see our data. So we're going to click on second and y equals, which gets us to stat plot. We want to turn our plot on. So if we click on enter and turn it on, and then tell it that we want a scatter plot using L1 as our X list and L2 as our Y list. And let's make a small little dot for a mark because we have lots and lots of data here. And then the next thing we need to do is zoom to the stat area, which is 9. So it will calculate or look at the data and adjust the range and domain accordingly. And there's our logistics curve that matches our data with the exception of this outlier. So I took this one step further and I plotted the data on the Desmos graphing calculator online, and then also plotted the equation that the TI-84 Plus came up with. And as you can see, the curve looks great here as well. And this can help us predict when we will see, this can help us predict when there will be no more new cases. We're looking for that S-curve to flatline and become flat. We're looking for that S-curve to flatline. So here we are at 300 days after the start of this epidemic. It looks like 25, 50, 75 days into the epidemic. It looks like 25, 50, 375 days into the epidemic. Provided prevention methods and medical care continue to win this battle, we will have no new cases. This function predicts this should occur around the first week of April. To download the data or read about the process you've seen here, go to systree.com and search for Ebola 2014 Revisited.